Hello, I'm Steve Lipner, the Director of Security Engineering Strategy in Microsoft's Security Engineering and Communications organization. We're the organization that develops and implements the security development lifecycle for Microsoft, and I've actually been with the security development lifecycle since its beginning or before. What I'd like to do with these few slides is to provide you some of the background of security at Microsoft and the security development lifecycle, then introduce the concepts of trustworthy computing that underlie our work in security, privacy, product reliability, and business practices. And finally, talk about the origins of the SDL and the principles that underlie it. This introduction will provide you with the background for the remaining presentations on this DVD and also for the content of the book. Prior to the early 90s, Microsoft had built products that were designed to be used by one user at a time on a dedicated personal computer. For that reason, security wasn't really a challenge or requirement for the products that Microsoft built. Windows NT marked a break from that pattern because Windows NT was designed as a server operating system or time-sharing system where users might not trust each other and not all users might not be authorized access to all the information on the system. Windows NT was designed by a team of people who had previously worked on time-sharing systems at Digital Equipment and had extensive experience in building systems with robust operating system security. And NT was actually designed to meet fairly stringent requirements from the U.S. government security evaluation process of the time. Windows NT incorporated many security features such as robust login, the secure attention sequence, Control-Alt-Delete, and access control lists and auditing that were mandated both by government requirements and also by just good practice for multi-user computer systems. NT was designed in an era before the web, but by the time NT 4.0 was rolled out, of course, the Internet was widely used. The web was an important factor in computing, and so NT was faced with the challenges of operating on the Internet and operating with hostile attack. The big challenge that faced both NT and Windows 95 and Windows 98, which were developed roughly in parallel, was really the challenge of providing a secure Internet server and a secure Internet browser. And what we found as the Internet became widely used was that people started to experiment with the security of the systems on the Internet, both by doing penetration tests or breaking in or defacing websites, and by building websites that could attack browser users and cause hostile code to run on their machines. In response to those challenges, Microsoft steadily increased the level in investment both in server security and in browser security. Initially, the response team operated by accepting reports of vulnerabilities in Microsoft products and working with the product development teams to build fixes and ship them on a Microsoft website, as well as communicating with the finders of security vulnerabilities and providing information to users to ensure that they'd install the updates. The security response team was the precursor of the Microsoft Security Response Center that still operates today with much more robust processes and a much more capable team for dealing not only with reports of vulnerabilities, but also with of all manner of Internet emergencies. As vulnerability reports came into the security response team, Microsoft found that it needed to step up its investment in secure development practices to deal with the new threats and challenges that the Internet posed. And internally, Microsoft launched a security task force, an ad hoc assembly of people from across the company to look at the security problems that were facing Microsoft products and try to understand what kind of development practices would be needed to better meet those challenges and to produce software that wouldn't have as many vulnerabilities and wouldn't need as much of a security response. The Security Task Force made a set of recommendations that really mirror in some ways the content of the SDL as we see it today. Those included focus on threat modeling. They included use of automated tools to detect potential vulnerabilities in code. They included developer training. They included penetration testing and code review. And they included a number of other areas that we'll get into in the book and that really foreshadow the things that are in the SDL today. After the Security Task Force completed its work, Microsoft created the Secure Windows Initiative team. The team I work in today actually still refers to itself as the Secure Windows Initiative, although today our scope is Microsoft-wide, including essentially all products and services that the company releases. At the time, the Secure Windows Initiative was created to take the lessons of the Security Task Force and roll them out across the Windows division. And the initial concept of the Secure Windows Initiative team was actually to do design and code reviews of individual features in Windows and file bugs, basically ask for correction of problems before the product shipped. The Secure Windows Initiative team was initially tiny, fewer than 5 people, and complemented by the Windows penetration team, which was a test team that was targeted at looking for security vulnerabilities in Windows. While the Secure Windows Initiative team pioneered some interesting activities and did good work for its time, its scope was nowhere near the magnitude of the problem given the size and complexity of the Windows operating system. Microsoft realized that, and before Windows XP was launched, the Secure Windows Initiative team shifted its focus from reviewing code and doing design reviews itself to helping teams build automated tools that would find security vulnerabilities before product shipped, and helping to train developers, program managers, and testers to do their own security reviews. This has been a constant focus of Microsoft's efforts over the last 5 years, seeking approaches that are much more scalable, that can be applied by developers rather than having to have a few security specialists put the security into products. This is an approach that was pioneered by the Secure Windows Initiative team, and as it's matured, it's really the approach that's come behind the SDL and proven to be effective in making the SDL scale to the products Microsoft ships. While the Secure Windows Initiative team was launching and getting started, we found through 2001 a number of discoveries of serious and in some cases embarrassing vulnerabilities in Microsoft software. These included the launch of the Code Red and NIMDA worms in 2001 and a vulnerability in the newly released Windows XP operating system that demonstrated to us that we still needed to do more. In response to this increased emphasis on finding vulnerabilities and launching worms that exploited vulnerabilities, Microsoft product teams started to look for better ways to address the security challenge that they were clearly facing. The first team to do this was actually the .NET Framework and Common Language Runtime team that was launching the first release of a new runtime environment for managed code. That team found that the vulnerability rates that its penetration testers were finding were not what they wanted to be, and so they took the pioneering step of stopping all development before release, slipping their ship date, and focusing their entire team on looking for and fixing security bugs and on changing the profile of the product so that even if attacked successfully, vulnerabilities wouldn't have as serious consequences. The .NET Framework security stand-down really pioneered many of the approaches that are incorporated in the SDL, and also had a major impact on releasing a secure product. The .NET Framework has been out for almost 5 years now, and the vulnerability rate has been very low compared to comparable managed code frameworks in the industry. As the .NET Framework stand-down was completing, and as it became evident that we had to do more given the challenges posed by worms and discoveries of vulnerabilities. Microsoft's senior management was looking at a broader approach to really change the scope and focus of development across the company. That broader focus came to fruition with what's now called Trustworthy computing. Trustworthy computing is really an umbrella with four individual pillars underneath it: security, privacy, reliability, and business practices. As shown on the slide, the security pillar focuses on security against attacks and on products that can protect the confidentiality, integrity, and availability of data and systems. The security pillar of Trustworthy computing also includes manageability, the notion that security not only has to be present, but it has to be controllable by the users who own the systems and operate them. Privacy is about protecting the individual and personal information of users of Microsoft systems. And that includes preventing unwanted communication, preventing unwanted sharing of information, allowing individuals to control what will be done with their information, and ensuring that online services provide appropriate information to users about how their information will be shared, and allows them to make appropriate choices and exercise appropriate controls over the use of their information. Reliability is something that I think we all understand. That's about ensuring that the systems and services that we provide have predictable and resilient behavior, that they don't go down, that blue screens are as much as possible a thing of the past, that systems are recoverable when failures occur. And finally, business practices talk about open, transparent interaction with customers, about providing customers with clear and honest information about the way Microsoft does business, about the attributes of its products, about providing industry leadership, for example, by sharing the results of the security development lifecycle, and about embracing open standards in a way that allows users to understand what products do. With the background of both the Secure Windows Initiative and the .NET Framework Security Stand-Down, and with the overall commitment provided by the Trustworthy Computing Initiative, Microsoft went forward in a significant new direction to launch what became the Security Development Lifecycle. Around the end of 2001, the operating system release that became Windows Server 2003 was in beta and in its relatively late stages of development. In order to ensure that the security of Windows Server 2003 was what it needed to be, Microsoft took the step of stopping all development on Windows Server 2003 and conducting what we called a security push. The security push took the lessons that we understood from the Secure Windows Initiative and applied them across about 8,500 developers that made up the Windows Server 2003 development team. To do that, we first provided training to all those 8,500 developers and then sent them back to conduct threat modeling, to conduct code reviews, to conduct attack testing and negative testing to try to find the security vulnerabilities that might be in Windows Server 2003 and remove them before the product released. We also made around 100 design changes to Windows Server 2003 with the aim of making it more secure by default and reducing its attack surface. Basically, changing the product so that even if vulnerabilities remained, it would be harder to exploit them, harder to take advantage of them in the default configuration. You'll learn about attack surface and default security as you read through the chapters of the book. The Windows Server 2003 security push was initially planned for about a month, and we wound up taking the team, all 8,500 people, offline for more than 2 months as we focused on security and made changes across the product. Once the security push was complete, we went on to test the changes that had been made during the course of the security push, implement some of the design modifications, and continue with the process of bringing Windows Server 2003 to market. The product as shipped was much different from what was initially planned because of the impact of the security push on the design and implementation of Windows Server 2003. Later in 2002, after the security push was complete and the product was well on its way to shipping, the vice president responsible asked the Secure Windows Initiative team, well, I know what you've done, I know what the security push achieved, but how secure is it? And that question led us to conduct what became known as a final security review, an independent review of the product incorporating work by both the Secure Windows Initiative team and penetration testers hired from outside, contracted from outside, to look at the product and determine how good is it fit to ship. Additional changes to Windows Server 2003 resulted from the final security review, and in total, the product was delayed by several months because of the work done in the security push and the final security review. But the net result was worth it because the results of Windows Server 2003 as shipped in terms of discovered vulnerabilities in the fielded product have been much better than those of its predecessors, Windows NT and Windows 2000 Server. In addition to the security push and final security review on Windows Server 2003, other products, including Office, Exchange, and SQL, conducted their own security pushes, either on new versions, in the case of Office 2003, or in the case of service packs for Exchange 2000 and SQL Server 2000. And those security pushes resulted in their own very significant improvements in the vulnerability rates experienced by the products or service packs that were shipped. With the confidence gained by the various security push efforts and by the reduced vulnerability rates that products that had gone through security pushes were experiencing in the field, Microsoft went forward to formalize the security development lifecycle. In late 2003 and early 2004, we developed documentation, process guides, and associated tools and teams to formalize every aspect of what had been done informally during the various security push efforts. So today, there's a documented security development lifecycle that teams at Microsoft have to follow as they ship, including things like threat modeling, the use of tools, independent security testing, final security reviews, and other aspects that lead to a more secure product. And today, the security development lifecycle reflects that formalization across the products that Microsoft ships. The SDL isn't static. One of the jobs that our team at Microsoft does is to update the SDL every 6 months based on new threats, new kinds of vulnerabilities found, new kinds of tools that can lead to more secure software, and new lessons learned to make Microsoft's products even more secure. The SDL isn't a static thing, a document or a process that's cast in stone. Instead, we update it every 6 months as new kinds of vulnerabilities are discovered and as we discover new ways to make software more secure in anticipation of vulnerabilities not yet discovered. We also update the SDL on a continuous basis if new vulnerabilities constitute urgent threats to Microsoft software and Microsoft customers. The content of the book that you'll be reading talks about the SDL as we practice it, including the ways that we update it and the key practices that we found to be effective at reducing vulnerability rates in Microsoft software or in any other software that faces security challenges. I hope that you enjoy the book as well as the rest of this video, and that you learn from it and are able to take our lessons to heart and make your own software more secure for the benefit of all our customers and the Internet ecosystem. Thank you very much.